Hello, this is Paul from Tech. In this video, let's prove a theorem 3.3.2, which is the projection, orthogonal projection theorem in space. It states if we have a u and a vector u and a direction, or which is another vector a in space, we can do orthogonal projection of u onto a. Okay, that means u can be decomposed into two vectors, and the first is w1. W1 is just along with a, okay, along a, and the w2 is another component which is perpendicular to a, and the decomposition should be unique. The size exact one way. Okay, so we will prove why. If the way is unique, so therefore along a means parallel, right, to a. That's a scalar multiple of a. So we call it projection, which is this coefficient times a. That's w1. What is w2? W2, of course, is another component. You use u subtract w1, you get w2 unique. If w1 is unique, then w2 should be unique. Draw a small graph. So you see what does it mean? It means if we have a direction, here is a. If we have here is a vector, is a u. Okay, here in space, keep in mind, and then we can do decomposition to orthogonal decomposition, and this is a 1, okay, which is w1. And another decomposition, see, this vector is the component of u along a, and another is the component, let me draw perpendicular here. Okay, this is another. You see, this form a parallelogram, or because this is perpendicular, see, it forms a rectangle, right? Okay, so this one is w2. This is w1. Sorry, this is a w2. Okay, by the sum, this side is w1 plus w2. Of course, is u, right? So u decompose into the sum of w1 plus w2. Yeah, quite simple, right? So w1 is along a, w2 as a perpendicular to a. Look, it's unique because at least in two spaces unique, and but the result now is in space. Okay, and can we find a unique decomposition? And what is the decomposition? And decomposition says here the w1 is the projection. We give a name. See the projection here. This is w1. Therefore, w1 is a scalar multiple of a, right? And it is the coefficient. I will simply say this is a number, constant number k. Yk has this form. We need to prove. And then the second, if you find out what is w1, and therefore another component is w2. U minus w1, of course, is w2, right? So this should be w2. Now let's prove why. It's quite easy. We only need a little bit. So look at it. If we can solve w1 and then find that the solution is unique, therefore the decomposition is unique, right? So we directly solve what is w1. So first, let's break it down. Let's set up that u can be decomposed into a way of w1 plus w2. w1 is along a, which is a multiple. So w1, see, this is the projection. So I can set up is a k, which has to say a constant number k times a, right? So this is w1. I don't know what is a k. I also don't know if k is unique or not unique. yeah, and space. But if we find out k is unique, then the decomposition should be unique. Then what is W2? Of course, I don't know. It's okay. The basic W2 should be orthogonal or perpendicular to W1, which is A. One more is W2 should perpendicular to W1 or A. Right, and then we solve. How to solve? So we have to use the dot product because the dot product of two vectors which are orthogonal to each other is 0. I use that property. So we do calculation of u dot A. Okay. See, u is there. Let me put u is k times A plus W2 dot A. What do we get? We get k times A. K times so this k is a scalar number. K times A dot A. The first distribute, of course. Distribute. And then what the second term? The second term is W2 dot A. Okay. So the second term is exactly 0. Because see W2 perpendicular to A. It disappears. It doesn't disappear. So what do we get? We get equals k times the normal of A squared. We have this property before, right? See, this is equation. Can we solve for k? K is unique. Okay, this k is unique because we have one parameter, a linear equation for k, right? See, we solve for k now. Easy. We get a k should be the dot product over the norm of A squared. U and A both are unique, so the numerator is unique. The denominator, of course, is unique. Therefore, k is unique. See, this is a unique. Therefore, the decomposition is also unique. Therefore, the decomposition is also unique. And that's the proof. Because we find a k. If we back to search, k exactly is the way that we have. That's all. Thank you.